16 different teams from 11 different countries competing in the final event of DARPA's Subterranean Challenge here at the Louisville Mega Cavern. We have virtual and systems competitions happening simultaneously, and welcome inside our broadcast position. We are inside the Louisville Mega Cavern. I'm Cameron Irwin, your host, alongside Julia. This is Dr. Julia Badger, our technical commentator and program manager, Dr. Timothy Chung. Welcome in. It's going to be a great day. We've got a lot to get covered in DARPA's Subterranean Challenge, and if you're just joining us on this day of coverage, my goodness, the mission of the Subterranean Challenge is to build autonomous systems that can rapidly map, navigate, and search through underground environments like tunnel, cave, and urban. Now, we've covered a lot of stuff in the last few days, but it's coming down to today. We've got one final world left on the virtual competition and the prize round, yes, in the systems competition. So it's time to get into this a little bit. I know, Tim, this has been your baby. This is years in the making. I mean, we finally made it to the last day.
We made it.
How excited are you to get to this point?
I am beyond excited. This is just so phenomenal. It's been so rewarding to see all of our teams come together to tackle the challenges of these underground environments that DARPA's created for them. It's been so rewarding to see the team's camaraderie, their commitment, their dedication to bring these technologies to the front.
And Julia, for you, I know it's been so exciting for you to get to see kind of the journey of this in just a short period of time in the advancement of technology. What are some of the things you've seen in the last few days?
Well, I'm just overwhelmed at how much everything has been pushed forward from a technology standpoint. And for Tim, actually, I think that it would be really nice to understand, where do these technologies go from here?
Yeah, that's one of the most exciting pieces about a DARPA challenge like this, is that there's no limit to where these technologies might end up going. We're going to see whole new sectors, I think, be able to sprout because of the technologies that we've developed here, whether that be through startup companies or supporting our warfighters and first responders directly through some of the insights that have been gleaned from their efforts here. I'm just overjoyed with the types of contributions we'll be able to make and have that dramatic impact.
So one of the unique parts of the virtual and systems as we go through these competitions today is the course that has been designed here. It is the triathlon of courses. It's tunnel, urban, cave, all combined into one. And this is true for both the virtual and the systems course design, which is going to bring me on over to two of the people that have worked relentlessly through this course design. It is our virtual competition lead, Angela Mayo, along with Victor Orikov, who is our systems competition lead. They're going to take you through the course and how it works. Over to you, Victor.
All right. So yeah, because the three subdomains don't really exist in any one location, we had the privilege of building a grand course that includes both all of the three subdomains, urban, tunnel, and cave systems. And so this is a fly-through video that shows you just the scale and scope of what was built here at the Louisville Mega Caverns. Now that we've seen what it looks like from the outside, let's take a look on the inside. Here we have the overall map of the course, and you can see that there's an urban section in orange, blue section is the tunnel subdomain, and then green is the cave. And this is the starting gate. As teams arrive, they don't know what the course looks like. All they know is that one entrance. And so they start there. Other than the starting gate, it's a completely unknown environment that they have to enter. So again, urban on left, tunnel in the middle, and cave on the right. So let's take a look inside. As we fly through, we'll try to highlight some of the challenge elements and unique features of each of the three subdomains.
And as we fly through, we'll realize that this is also the virtual World 8 that virtual teams are going through. So we're kind of merging the systems and virtual competitions here to send teams through both the same course.
All right, so let's start off with the tunnel subdomain. And so tunnel really is characterized by fairly unique, fairly consistent cross sections, but a lot of terrain obstacles. So we had everything from rails and mud to water. We had fog in the back and muddy sections. This shows you the rails that present a lot of challenges to the robots. Another element of the tunnel subdomain is just the scale and scope of it. So a lot of mines and man-made environments like this are just go for kilometers and kilometers.
Once we get into the urban subdomain, you see again those rails that legged robots and wheeled robots have to go over, stairs and vertical areas that UAVs can explore, and lots of urban themed obstacles that teams will have to go through.
Here we're passing by a mezzanine level, so a lot of urban environments are just highly complex. There's side rooms to explore, but also mezzanine levels at different heights where maybe a ground robot can't explore, and so a team of both ground and air robots might need to work together, including areas like this warehouse section where there's a lot to explore down on the floor level, but there's also shelves really high up and also a mezzanine level where there might be artifacts hidden. Now we're back to the rail section. This really presented a lot of difficult challenges to robots, just like the tunnel section rail. The urban rails are have always been a challenge, but those are much larger and wider than the tunnel sections.
Once we get into cave, we get into very constrained passages, and then here you see where actually the raw Louisville Mega Cavern scan was used, and the raw course is what teams get to explore in this area.
And that really is just a consistent theme in this course. There's a lot of constrained passages. There's also a lot of big open areas. So we saw the warehouse, we saw that large cavern. There's several other cavernous areas. And this is really difficult for robots, which are often developed to specialize in a certain environment. And having sensors that can do that can handle both constrained passages and large open areas and explore the different exploration algorithms that are required is a really unique element of this course. And here we're circling back around to the starting gate. So that was a quick fly-through tour of the course. Over to you, Cam.
Great job, Victor and Angela. Now I've got a couple questions for you guys because you spent so much time designing this court along with Tim, and even Tim sitting here while that was going through, and Julia saying, wow, that was a really tough course. A little bit evil, but you know, these systems, they're having to deal with these things in reality, right?
Absolutely.
So what were some of the inspirations for you guys to be able to build this course? I know that you guys went out and even surveyed certain areas to be able to make it as realistic as possible. Victor?
Yeah, because we had the opportunity to build a course here at the Louisville Mega Caverns and we wanted all three subdomains, we really spent a lot of time going around and getting inspiration from some of the courses that we used in the circuit stage of the competition. So gold mines, coal mines, the nuclear power plant we were at for urban, and we also, like you said, went around to several different caves across different geological features to actually scan them and use them as inspiration for this course. And the goal for that is really to have a representative environment that captures all of the challenges of the real world out there. And so we were able to capture all those and build a course that brings all of those challenge elements together in one really complex and really grand scale competition course.
And now you mentioned the challenges, right? And I'm going to send it to Angela with this. I mean, how do you know what challenges to include and maybe not include? Because it changes per subdomain. How do you make the choice?
Right. There have been challenge elements that teams had to deal with at each of the circuit stages, and we really tried to bring them all together in this. So in tunnel, you saw the rails. In urban, you saw stairwells and mezzanine levels. And in cave, obviously, the constrained passages that systems teams didn't get to deal with in the physical realm due to cave circuit. But we ended up mashing them all up together and also being able to use parts of the raw Louisville Mega Cavern as parts of the course, which is amazing.
That's absolutely amazing, and we're going to send it back towards this direction because, Tim, I mean, one of the competition objectives is to have this circle, right, from virtual to reality back to virtual, and you're really seeing this as a merging point when we look at the course design, and especially it's World 8 for the virtual competition.
It sure is. This convergence of virtual and reality really helps us understand both the limits but also the capabilities of the technologies that we're developing. By merging simulation and the physical, we get some insights that will help us understand where there's still room to grow, but also the things that we can maybe potentially have an impact immediately. And I think that's the true contribution of the Sub-T Challenge.
So we've seen the advancement of technology, but we've also seen the impact immediately. So I want to first thank you, Angela and Victor, for joining us and walking us through. You guys did a phenomenal job. Thanks, guys. And I'm going to send you on off, and we're going to head back on into the virtual. Let's take a look at exactly how does this competition work. This is the DARPA Subterranean Challenge.
Here's how to win an event in the DARPA Subterranean Challenge. Find the most artifacts in the shortest amount of time. When, or if, a team's system locates an artifact, it has to report not only the type of artifact, but also its spatially referenced location to an accuracy within 5 meters. A valid report earns 1 point. But teams are granted only a limited number of reports, so they can't just guess until they get lucky. Sound easy enough? Think again. Teams have to send their systems through dynamic terrain, over, under, and around obstacles, in austere navigation conditions, pushing the limits of their endurance, and in conditions degrading sensing capabilities and severely constraining communications. So teams need to be agile, adaptive, and accurate if they want to emerge victorious in the Sub-T Challenge.
So these teams are looking for artifacts throughout the course, and it's important to note the difference. Our teams have been going through the preliminary round, but it's time to head into the prize round, at least for the systems competition. We've been walking you through the last several days through the prize round on the virtual side as well. So those preliminary artifacts are up top. You combine those in with the prize round. So there are 10 total artifact classifications out on course, and you can start to scan through and see why these might be useful or relative to a real-life disaster scenario. You can see the survivor, rope, vent, backpack, fire extinguisher, and I love the final cube. This is the big one here at the final event of DARPA's Subterranean Challenge. It's kind of the Easter egg you have to find. Here's more on the cube artifact.
The cube artifact will serve as the 10th and final artifact, and has been specifically introduced for the Subterranean Challenge final event. The cube is a 3D representation of the Sub-T Challenge official logo, inspired by the Platonic solid for the Earth, which is a cube, and captures the distinctly three-dimensional nature of the underground environments critical to the Sub-T Challenge. The cube artifact is 3D printed using a translucent plastic material and will be illuminated from within by RGB LEDs that rotate through the color spectrum, and will include a Bluetooth radio that emits a wireless signal. Teams may attempt to localize and find this item through visual cameras, detecting the shape through LiDAR, or by detecting the wireless signal.
And now it's time to head into our virtual competition. These are your field of teams. We have so many, and there's actually 4 crossover teams between the virtual and the systems competition, from Coordinated Robotics, Columbia, Dynamo, Robotica, Marvel, CTU Krasnodar Lab. We got Team Parks as well, Flying Fitches, and Sodium 24 Robotics. 9 total teams on the virtual competition. And here is where we stand, heading in to the final world, world number 8. It is called the Subterranean layer. We'll get into seeing all of those worlds as we go through, and you can start to see World 1, World 2, World 3. And what's important is each of the solutions these teams submitted, they are run 3 different times on each of the worlds, and every single point matters from each of those runs, which ends up with their total world score, and then heads on over to the right side of your screen for their total score up into, we head into world number 8. So you can see Dynamo up at the top, CTU, Crass, Norlab has done very, very well. And I love to see Marble. Man, the team out of Colorado, they've been tough too. You're gonna see them in the systems competition as well. So I mentioned we've got 8 different worlds. Let's take a look at some of those worlds. As actually, instead, we're gonna head right on in. This is gonna be our first highlight. We're looking back now. This is the last world. This is Sub-T Lair. This is Team Dynamo going through with a UAV. What do we know about them, Julia?
Well, we've talked a lot about Team Dynamo's layered approach to control. They have separated their architecture and put it into, the high-level goal, following goal-based frontier development, and then they have a local planner that says, okay, I see this space ahead of me, how do I get through it? And then their model predictive controller at the very bottom of that. And we see here that it's doing pretty well. I mean, there's a lot of tight constrained spaces. It's going pretty slow through this very kind of the rubble, it's getting close to the walls here and there. It's trying to really feel its way out.
Yeah, so it definitely has to feel its way out. I mean, so many decision points for this team.
Absolutely, and I think that a lot of this kind of comes to the model predictive controller. And so we'll try to show you something here. You see it kind of getting close. But right here, we're going to look and see how it, crashes right into the wall and it dies a terrible death. But anyway, it was a very, very good try for Dynamo.
For Team Dynamo, definitely some difficulty as those UAVs, they've got to be able to get over those rails, fly around and explore all sorts of different environments in this world number 8, as here is now Team Columbia. Let's see what they have in store for us here on Sub-T Lair.
Columbia also came out with its drones going directly in there. Because the space is so constrained, and you're going to hear us talk about that through this whole first 10 minutes, at least.
For sure.
it's actually maybe not the best strategy to send out your drone first. Obviously, they don't get to pick because this is, like Cam said, the same controllers that are going into each one of these worlds. And they pretty quickly find that it is a little bit difficult to get those drones to go. So we're just watching it essentially explore here.
And I think it's also important to note, we've talked about it throughout our coverage, but on the virtual competition, one of the huge points of emphasis is its true autonomy. You submit the solution and you are completely hands-off. You're almost a little bit helpless thinking, all right, here you go, child, sending you off to school. You got to be able to do what you need to.
Absolutely. And so it's going into the urban environment, and we've been looking at this for the last couple days in the systems competition. It's trying to decide kind of where it's at. This is a little bit less constrained of a pathway, and so it's doing a bit of exploration. It does have some corners to go through here, but one thing that is to note that once you get into these hallways with these really smooth walls and it's kind of just all the way down, you don't have anything until we hit that, I think that vent there down a little bit. It makes it a lot harder for the LiDAR and the localization to really go.
Yeah, some major challenges. Not only are they constrained passageways, but without having any real ID points, right, along that wall can also be very challenging for the sensors on board for so many of these systems as we head on into Flying Fishes. And this is just within the first 10 minutes. We're taking you through this. This is fantastic. So we're going to go through chronological order, at least somewhat relatively, as we head through this world number 8, Flying Fishes UGV. Taken off, and I gotta love this. I think that might even be that same hallway from a different view.
It is. It's just looking at the robot, but it's rolling through the same way as we saw. It's finding a bunch of artifacts. We saw the vent, it just looked and found something else as it kind of rolls into our subway station part more.
And you can also see the total number of attempts pop up, like you mentioned. Their score is on the left side of your screen, so that hopefully will be ticking up further and further as that 60-minute window continues to decline. You also have that map, that orange arrow, that's this current UGV.
Absolutely. So as it continues to go, if you remember from earlier, there's some stairs coming up here, and so it's been dropping some nodes, some breadcrumbs for communications, getting through those poles, which is great. But rovers, even with big wheels, are typically not the best on stairs. They just are not the ones to use. So let's see if it knows what to do once we get up to it.
Some of those stairs, just one of the many challenges. You also have the elements of light and darkness, maybe some mud and water. You have dynamic obstacles. That means something could potentially happen to change the course, and these systems aren't able to get back from where they came from. Or maybe a new system can't necessarily traverse as this UGV. Yeah, those stairs are directly in front of it. So actually, it's almost as if you are the stairs when looking at your screen. That yellow is just beneath, and this is another really emphasis on detail from DARPA's exploration into this world. They even add in the things that you would see in maybe that subway station. The yellow, a huge indicator of a hazard. So a lot of these sensors, they're able to pick that up as well.
And I love here that they had a mural done on the walls, and they have everybody's names in there. And so if you're a team, look for your name, it's there.
Yeah,
it's pretty
you can
cool.
see coordinated robotics right there on the right side. Team Barks popping up as well. CTU Krasnorlab, it passes through. I mean, every inch of this course, whether it is in reality or in virtual, I mean, it is to a T. Perfectly done. So much detail and so much thought put into this. As we head on into CTU Krasnorlab, one of the other important pieces to note is 7 active robots already on the course, and we're only 4 minutes into their run.
Yep, we are passing by some of our friends here, and we're getting into the tunnel section. We did pass by a drill there at the start. We're going to see it kind of go back and forth, so I wanted to see if I could kind of show you some stuff that was going on. Kind of right behind here, I just missed it, is a, I can't draw. Never mind. We will keep going.
We were hoping to give you a little bit of telestrator.
We were hoping to show you, but you'll have to just kind of look for yourself. But there's a sign, and right underneath it is a fire extinguisher, and it's going back and forth around that. I'm not quite sure if that's what it's doing, is trying to localize that, but that was the best conclusion I had on watching this video. So just if you're getting dizzy, which I did, it is trying to get that other that score in there.
So all sorts of different methods by which these systems are trying to get through this. We talk about planners all the time. What are the objectives of each of these systems as it passes the survivor? We'll maybe dig into that as we head to our next clip from Team Barks. There again is that survivor artifact, and this UAV, yeah, stuck between a rock and a hard place, or more so just on a rock. Let's head on over to Team Barks. Again, just within that first 5-minute window as they get their UAV off the ground and in. And we talk about exploration. I mean, what are some of the ways in which these teams kind of plan out and strategize that method?
For exploration, so one of the ways that you'll see is a breadth first search. It's hard to say, but what it's trying to do is essentially get as much breadth, so to see kind of the extent of what it has is for frontiers without necessarily digging deep into any of those frontiers right to start. It can be kind of frustrating for the viewer, because what that means is it goes back and forth a lot to try to see what are all the options before it goes on and then figures out which one it's going to go deep into. Depth first then is another kind of way to look at it, where you find one, you go deep, and then come back out.
You know, maybe we have a viewer that is seeing robotics at this level for the first time. So can you explain a little bit about, you talked about frontiers, define that and explain what exactly they are.
Absolutely, great point, Cam. So frontiers is one of the main ways, not all teams are using it, but it's essentially where you come to a decision point or a doorway. And so they call that a frontier. And the reason it's a frontier is that beyond that doorway or beyond that decision point, there are unexplored things. So if you have explored one path and you come to a decision point, it no longer is a frontier, right? Because you know what's to come after that.
So a little bit of a different approach in terms of exploration. You're going to see that as we continue through these teams. So speaking of different teams, let's head on over to our next team. This is going to be another look at Team Dynamo, still within that 10-minute window, within those first few minutes. Let's see what Dynamo is able to do. It looks like this is a pretty constrained passageway and kind of cluttered up into the urban space.
Yes, this is this we saw in the systems. It was hard for everything to get through, and not a lot of our UAVs did a great job in going through these doorways, but Dynamo actually does a pretty good job. Now, we saw in that first video that it has some trouble there in the cave, but you see it knocking into the doorways a little bit here, but it's able to do a pretty good job of navigating its way through that more constrained passageway. In fact, I have notes to say that some of these are only 1 meter wide, and some of these UAVs are close to that wide just themselves. So I know it's hard to kind of tell scale, but they are pretty big.
And Dynamo, I think one of the cool stories is they came into the DARPA Subterranean Challenge just a subdomain ago. Their first competition was back at Cave Circuit. They finished off with a 3rd place finish. They are led by their man Hilario Tomei, and they're using the X500. This is a system that almost, what was it, 4 of our teams from the virtual using all the same robot roster.
Absolutely, yeah. It's a fast one with good battery life. It's actually one of the more medium range ones. So if this is the 500, it's about 2 feet across, or 0.65 meters, I think, is what it is. And so it's a better one for the constrained passageways.
And that, of course, it has been modeled. We talk about collaboration. That has been modeled after CTU Crass Norlab's UAV. So Dynamo picking up that system as we head on into our next highlight. This is going to be from Team Marble. And I love this. It's almost like we planned this out. Look, it's a different UAV, and
right.
I'm assuming this might be a little bit bigger in size.
I think this one is. 0.9 or 0.8 meters across. So it's definitely bigger. But if you look here, what the other one lacked, the X500 lacked, was guards for its propellers. This one has those, and so while if you run into a wall with the propeller that is keeping you up, you are more likely to crash. In this case, this has more resilience. It's more robust to being able to gently bump the walls and kind of feel its way through, because it's not going to interrupt its source of lift, essentially.
Well, and that's a great point. We talk about different elements of each of these systems, and you can see almost a little bit of a shake there. Maybe it caught an edge, but there are different elements, right, that make certain systems maybe better for certain subdomains and different challenges it presents as this UAV continues through. But one of the other challenges that this competition has really focused in on is artifact identification. And you can see right there's a fire extinguisher, and that actually is reported as a backpack. It's also important to note we had 6 artifacts in the preliminary round. You head on in to that final round. That makes it a little bit more challenging. You have to correctly classify and locate within 5 meters to be able to put a point on the board. And that's where you saw that attempts come up, and it actually identified it wrong.
Well, the backpack is red too, so maybe that was a problem. Yeah.
Great point. So some of the sensors on here picking up different colors as well.
It's a pretty common way to, so the way that vision processing work, it takes a lot of compute power. And so people, I'm not going to say cheat, they help their cause, let's say that. Oh no, big crush.
Oh, that's a big crush.
But they help their cause by finding colors and filtering on that. It makes it a lot easier.
Just another way to try and identify what is down there. Again, this is a completely unknown environment for these robots as they head into the course. They have no idea what they're going to be confronted with. They have some ideas in terms of the challenges, but the course, absolutely not. As you take a look at Team Barks, they're starting to head on in. There's those rails they do not have to deal with as a UAV. And another interesting note, as a dynamic obstacle comes and crashes, so that is no longer traversable to go backwards, but these rails change in the height. So maybe a system's able to go across them or traverse them at a certain point in the course, and then all of a sudden it's now 6 inches higher out of the ground.
Right, yeah, I know that, and that's what we saw in the real world too. They had it so that it was variable, and so you could be on one side or the other, and then all of a sudden that just didn't work out for your system. For UAVs, it's not that big of a deal because we're flying over it. And we see this one coming back and trying to say, hey, can I go back to where I was? And realizing it did collapse that rubble pile, and it does recalculate where it's going to go. Essentially, traversability went down, so exploration had to go up, and so it's going to go explore some more.
Well, you talk about exploration, and if you take a look at the lower right-hand side, you can see the map, and it shows all the active robots on course. Those yellow arrows are the other ones, the orange being the current UAV. And this team is looks like they're doing a pretty decent job of maybe expanding into different parts of the course. I mean, what are some of the algorithms or thoughts as they head in to try and get as deep and as wide and away from each other as possible?
Absolutely, and we've talked about this a little bit, but there's two major strategies that you use. You can kind of bunch all the solutions under. One is that you have some sort of global communication and you do a optimization, if you will, over that whole map. And so all of the robots are coming together to then be part of that decision, and they separate that way. The other way is to give each robot locally their own controller that's a little different, or tuned a little to be different than their friends, and then they all naturally somewhat separate to be able to accommodate that.
And that was definitely one of the switches we've seen from runs 1 and 2 and then into the prize round in the systems competition. Something important to note. It's kind of fun to watch as that changed and shifted through their runs, but again, we're still in that virtual world. So here's a look at where we stand. This is just within that first 10 to 12 minute range of world number 8. So you can see the artifacts correctly identified and scored. There's their success rate. That is in regards to how many reports they sent in and were correct. And then the map coverage also shows kind of the amount that they have covered as well. And again, they're in that order of our leaderboard just for this World 8 alone. That's the sub-T layer. So let's head on in to our next few points. I know, what have we learned? Because those first 10 minutes, that we saw a lot of different things from those teams.
Absolutely. I think the biggest takeaway from that is that this is a more constrained environment than we've seen so far in a lot of the worlds, and the controllers that we've been using for everything needed to kind of learn that right at the beginning, and so that's what we saw.
Yeah, and that was exactly my point, is kind of through those runs in systems, we could see how they changed their approach throughout. But again, in this virtual competition, they didn't get that opportunity.
Right, exactly.
They got challenged in the preliminary round, which happened prior to our setup here at the final event in the Louisville Mega Cavern. So now we're heading in past that 12-minute mark into world number 8. Here's a look at Robotica. And again, you're already seeing another UAV system from Team Robotica. They're actually using, looks like, a few different ones.
Yeah, so this one, it's going through pretty well on that long hallway. It's being able to be stable as it goes. One of the things that we haven't really seen so far in this world, where we've seen in a lot of the other virtual worlds, is elevation changes. We've seen it in the system, so you guys know it's coming, but it's going to basically the subway station, where hopefully it can use its abilities to go up and explore the different levels that we have once we pop out into the station, the tracks here.
We also, through our coverage, have talked about the time it takes for these systems to explore and identify. You know, are they stopping and looking at what's in front of them, or are they quickly localizing or figuring out exactly where they are and mapping and looking for these as they fly by? I mean, how are some of these systems able to identify things so much quicker than others? And it's not necessarily always an advantage at times. Maybe you miss something.
Yeah, you really do have to tune that, right? And you decide whether you're going to capture 1 or 2 shots as you fly by, which maybe reduces your accuracy, but you can handle that because of other reasons. Or you stop and you really take pictures at different angles to say, okay, I'm going to use a picture from here and then move a meter, picture from here, move a meter, picture from here. That helps your triangulation, which is the math that you do to be able to say where exactly is this object.
Well, and I believe that's what just took place too, is you can start to see some of those attempts scale up, but the points not necessarily doing the same. So maybe a little bit quicker in the search, but we'll see if Robotica, oh, there you go, couple scoring as they go there. Quick turnaround, 3 on the board now with 11 total attempts used.
Yep, and it's moving up a little bit in elevation and popping up to kind of the stage above there and seeing what it can do. And I don't think there's any way to get up there unless you're a UAV. So it's one of those, you have to go far back and do that exploration with that robot.
Have to get deep and then be able to get vertical. As we head into Sodium 24 Robotics at the 43-minute mark. That's what's left on their time clock. And you can again see the nearest artifact just about 4.5 meters away from this current system.
So some of the our teams have been trying to make their autonomy solution essentially robot agnostic. And what that means is that they want it to be a stack, a set of controllers that you can use regardless of what your robot's capability is. I think that works well for portability. You know what your robots are doing, you kind of have the same thing going on. It has a little bit less advantage when you've got the different capabilities needing to do different types of things. You have to kind of use top controllers for that. But we see here as we rolled past one of our UGVs, there's actually, if you look at the map down at the bottom there, there's a bunch of them kind of in the same area at the same time. And so this team, Sodium 24, is one of those teams that does use kind of that portability type of controller, and so sometimes this traffic jam that you're seeing now is a result of that.
A little bit of a traffic jam, but this team has participated all the way back from Tunnel Circuit in the virtual competition. They finished third there, then they went to Urban, also competed and had a solid finish at that 6th spot, and then Cave, they finished at 5th as well there, headed up by none other than Malcolm Stagg, another one-man team. I've seen a few of those. It's impressive that one brain can do all of that.
Oh, I agree.
So let's take another look at Sodium 24 Robotics, because I believe we've got another highlight coming from the Sub-T lair. And here is their track system.
Yeah, so we're gonna see the track system exploring in the urban section. It's gonna roll over a breadcrumb. So you know that somebody has been there before, right? Somebody dropped that. So this one is going to kind of go back and forth and figure out what it needs to do. We actually see this kind of behavior a lot, not necessarily for a good reason. Sometimes it's a good reason, but in some of the ways that, you know, people try to plan out their robot's autonomy, they're like, well, let's just follow a wall, and if you're in a square room without a door, well, then you're there forever, right? We call this a live lock condition, and so it's always something that you don't want your robots to get into. Not saying that it isn't here now, but it's one of those things that's, you know, when you're seeing these types of things, you never quite know if it's doing something that you wanted it to do and you knew it was good, or it's doing something you wanted to do and it wasn't good.
You know, and just out of the corner there of your screen, you also saw the poles right there. I feel like a lot of teams potentially had some trouble with those.
Oh, yeah. Particularly the UAVs.
Yeah, they don't like those. The rotors are not a fan of those poles. Let's put it that way. I believe we got one more highlight coming before we hit that 20-minute mark. Yes, we do. Here is Team Dynamo yet again, and you see the 40 on the screen. Looks like they're just launching off from the staging area. You can see where they've already got in terms of their score 5. And again, this is from Sub-T lair as they head on in.
The Dynamo's unique in this competition in that they only have UAVs. They had no UGVs whatsoever, so the 5 active robots that you see on the top there are all flying robots, and so having them come back out for this hour-long run and get a new battery, essentially, power back up is an important thing, and delaying its deployment into the cave is also a strategy that they have to use to be able to allow for this exploration as they go. So what you want them to do is to explore in different places, and so you saw it going into cave. I think it got a little messed up by how constrained it got so quickly. It just was very hard for it to fly. But what you don't really want them to do is to join them another UAV in the same hallway, if you will, which is exactly what we're watching right here. And so I call this the hallway death match. And so you kind of see in the bottom here that the yellow and the orange are coming together.
Oh dear.
A very slow speed, which is good, but you know, this is what makes great TV, right, Cam?
The anticipation is killing me.
Exactly.
Oh dear, oh dear. And
there we go.
Wow, they look like 2 love bugs. I was just in Orlando and it looks a little something like that.
Yeah, they did it. They managed to park themselves. Emergency landing did work, which is good.
Yes, they are officially parked. One of the challenges for UAVs, well, it's only so far they can go with certain battery life. And again, here's your scorecard. And I think I need to correct myself. These, again, this is the artifact scores just from their best run on world number 8. So make sure you take a look at those. So you don't necessarily see all the points they scored on this world, but that is from their best run. Now it's time to head on in. We're actually going to skip. Are you ready to do a little bit of time travel?
Ready.
All right, we're going to do a little bit of time travel. We're going to skip on ahead and figure out where exactly these teams are at in terms of their maps. So let's take a look at a couple of these maps, and you can start to see this is the start of Sodium-24 robotics, and we're going quickly, so obviously that 60-minute clock is going through so rapidly. And you can start to see the cloud size on the right side, the coverage, and the deviation. Explain what some of those might be.
So the green dots that you see filling out are when the sensors of the Sodium-24 robots come up with what it looks like inside. The orange dots and the deviation, you can see it in that lower right-hand corner, that 1% there. That is the dots that come back that don't match with our map. They don't match with the simulation. The higher deviation that you have, it is a risk that you have less ability to localize because your map is a little bit off. It's not a one-to-one, so you can't really just say, okay, this is how it's going to be, but that's what that means.
Well, that's a perfect description to head on into our next team. This is Team Flying Fitches as their map shows up. And again, we're starting at that 60-minute mark to show you as we go through, and look at how quickly and the depth they're already getting just within those 6 minutes, and you can see the deviation difference.
Yeah, you can actually see on that straightaway that goes up, if you look at like kind of how the corridor wiggles around there, the corners, it actually matches with something that is probably a 10-degree angle down further, right? And so those are not too bad at the beginning, so you're going to hit those points at the beginning, but as you go deeper into your map, that's really going to be a big detriment to getting that 5-meter accuracy.
And what are some of the things that can lead to that deviation?
So depending on how you're doing your simultaneous localization and mapping, it can be the errors in your sensors. And so what you try to do is correct yourself at different places to make sure that doesn't happen, but you really have to be really smart about your filtering and the sensors you choose to not make it happen.
Well, let's see what Marble can do in terms of their deviation and total map coverage to a certain point. You can start to see quickly getting on in there. The attempts also showing up still on the left side of your screen, as well as their score.
One of the cool things about Marble is if you look at the very top right-hand side, it says cloud size, and that is in numbers of points. And so you see 4K, 2K, it goes up and down. What's interesting about that is their map doesn't just build, it also removes points. And so if it finds that there are points in there that just don't make sense, it takes them out. So that's one of the ways, going back to your previous question, Cam, on how do you make that go away, is you can reduce your deviation by deciding these points aren't the right thing to do.
And it's pretty incredible to see how accurate that map is. My goodness, only 1% just within those first 20 minutes or so for Team Marble. Now let's take a look back. What have we learned to this point? Because we've now seen what the robots are doing just within those first 20 to 30 minutes, and now we've seen kind of the depth at which they've gotten into within 30 minutes. Does that surprise you?
No, it's a hard course, and so it's going to be a little bit more difficult to do. There's a UAV focus, as we remember from our virtual teams. Almost all of them have more UAVs than they do ground vehicles, and it's hard for UAVs to go through those really constrained passageways. So we haven't seen a whole lot of cave because if the UAV is going, it's going to be really hard for it to get through. We've seen a lot more of urban; those are more UAV friendly, and I hope to see as we move on a little bit more point scoring.
All right, well, let's see if more point scoring is on the agenda as we head back into our highlights. CTU Krasnorlab, and oh my goodness, it looks like those are 2 tracked vehicles. Getting a little difficulty on the inclines there.
Yeah, it's hard to see with the map, but man, that one went almost vertical, and I was like, this is gonna flip over. It didn't. So that was very good. We're actually following the UAV in this clip, though, so it's hanging out there. There actually is, in the systems, another way that you can kind of calibrate yourself, but that's not what's happening there, and it decides at this point, okay, the frontiers have been explored, where do I need to go? It passes by a UAV that's already on the ground beneath it, and I think it is trying to decide whether this is something it wants to explore or not.
This team is headed up by Thomas Svoboda, and this is one of our international teams, both team members coming from the Czech Republic as well as Canada. They've got 5 of the X500s on their team roster, along with two of Cyro Data 61's tracked systems, which we saw just at the beginning of this clip. That UAV just passed another one down on the ground.
Yep. So the breadth first searching, has you kind of go back and forth for a little bit, deciding where all the frontiers are. So that's why you saw so many robots kind of at the very, very top there. But once that frontier matching algorithm that kind of spreads out your robots triggered, and they decided who was going where, is really going to start digging in.
Got to dig into this course, and again, and I mentioned the pole.
You had it there, Cam.
And there it is. Such a deadly pole right in the middle.
It is.
And somewhere Angela is tuning in and giving a little chuckle there, saying, "You're welcome, folks. You're welcome." All right, let's head on into our next highlight. This is from Coordinated Robotics, that one-man team of Kevin Knadler. This is a team that has done exceptionally well in the virtual competition to this point, winning 2 of the 3 subdomains. They won Tunnel, then they took second at Urban, just behind Team Parks, and then Cave Circuit again with that first place finish at Cave not too long ago. That was just about a year. My goodness. Let's go. Time flies here at the Subterranean Challenge.
Yeah, so we see a little bit of a traffic jam as they're deciding which way they're all going to go. You actually could see a flipped UGV and tunnel there just ahead of us. So something happened there with that one. They're actually going a lot slower than Koro typically goes on all of these. For this one, it's definitely trying to feel its way around, hopefully catching some of the artifacts that we're passing in this section.
One of the interesting conversations we've had throughout the last few days, maybe off camera more so, is we have teams crossing over, right? And maybe their focus is more towards the virtual, or maybe their focus is more towards the systems competition. So this team has done exceptionally well in the virtual world. Why is that?
So as a software mechanical engineer myself, I would much prefer to write software than have to deal with hardware, and that's what I would guess, is that that's the way they like it too. And when you are kind of focused more on software, virtual is the better place to succeed.
That's a great point, as Kevin Knadler was a software designer previously, and then all of a sudden became a roboticist. So you gotta love it. The one-man team of Kevin Knadler, at least on the virtual side. So let's take a look at our scorecard now, and where we stand on those best runs through world number 8 up to this time. So we've got Coordinated Robotics, there you go, 7 points from them, Robotica up as well. That's a really good job by Team Robotica. And then Sodium 24 coming in at 3. So fantastic job up until this point through world number 8. Again, the recreation of our actual course here at the Louisville Mega Cavern. And my goodness, what do we know now? We saw the themes of the constrained passageways. That was very much at the forefront. What do we see now?
So we're starting to see some points getting added up because we are now separating our robots. We're now seeing that they're getting a little bit deeper or spread apart into our course. How deep they'll get, I'm not sure. I think with these fully autonomous algorithms, this course is just really hard. There's the 3 different domains, all of the details. It's going to be interesting to see how many points they rack up.
All right, let's see how many points they can rack up. I believe we've got a couple more things to take a look at as we look in on Coordinated Robotics. We're at that 20-minute mark. That's the time they have left. And this is one of my favorite places on the course. This tunnel, so gnarly.
It is. I was so excited to see some of our systems get through this at various points, but this one's very constrained. It's not tall enough to even walk through to give you a context of what this actually looks like, and then you wouldn't want to pass somebody on this hallway either. But look, it's very good, very steady controller going through there. It's quite impressive.
I actually did walk through this portion in the real world in the systems competition, and I'm 5'11", and I was ready to get down on my hands and knees and crawl through there, if that gives you any context. Just a very, very constrained passageway. As all of a sudden, then again, you see the crossover in between the subdomains, right? All of a sudden, we're back to some caved walls and the rails down on the ground.
And we're back to some speed, which is what everybody knows I like. We actually have it going through in the fog right here. It does slow down, but does a pretty decent job of maintaining its stability and forward motion even through it.
Well, we haven't even necessarily talked about the fog yet. That is one of those dynamic obstacles in this course, and obviously it heads to the reality, right, of what could happen in disaster situations. And this fog, it can cause a lot of challenges for the sensors on board. As this one makes it through.
Makes it through. It does a good job. When we get into kind of a little bit more of the constrained area, we actually passed a place where the elevation went up, and the UAV did not notice that. So that was actually kind of an interesting behavior.
And there's another rope just beneath on that left-hand side, and all of a sudden, again, wow, from one subdomain to the next, another different looking cave. And I think that's another element to point out, right? No cave systems are the same, right? No two, so different environments they have to deal with.
And actually being here in the Louisville Mega Cavern, this is not really what their caves look like, but they made it so that we would crash the UAVs just like that.
We just want to get a little bit more challenging.
Exactly.
All right, Coordinated Robotics, that is a downed UAV. That's kind of a theme throughout our competition, but hey, at least they got some exploring done. Just 14 minutes left as we take a look back in on Team Robotica. Let's see what their UAV can do. Some of the sensors on board, that RGB depth camera and some LiDARs, those pointing in different directions, try and pick up as much information as possible.
So it's not really surprising to me anyway that you see the UAVs in the cave section near the end of the run. Really, you've got to get to where exploration is a higher need than traversability. You want to be a bit more conservative with your UAVs in the beginning of the run, and then at the end, you know, hey, this is for all the marbles, so we've got to do it. I call this section the drone graveyard, and if you look right there, there's one down, and then over on the up on the top, kind of in the tunnel there, there's two more. We'll get over there, you'll see them. But this is just, they all got stuck.
It's very challenging, and there's one of those cell phone artifacts just beneath, and then all of a sudden, this is the perfect view right here, right? You see the challenges all coming in, the subway platform, then the fog coming in. There's another UAV. Actually, there's two more, so you've now got 3 on screen. You also saw a backpack up on that second tier. So much exploration having to be made by these systems.
It's clear that the fog is not something that Robotica is handling terribly well with its filters or controllers. There's 2 UAVs stuck in here, and then the one that you see behind that was down that we passed just a little while ago. We don't know what took that one down, but it could be the fog from there too. It just kind of going through it and not being able to get through it there. So we'll see what this UAV does.
Well, now that we've seen Robotica again to kind of struggle with that UAV and the fog, here's a look at their map. This is going backwards a little bit in time. Yes, we do time travel here at the DARPA Subterranean Challenge. So that 24 is on the board. You can start to see the deviation, not too much out in front. And the map coverage now at 30%. And I'd love to see it climb as those attempts do as well.
Yeah, it's looking pretty good for as deep as they've got to have the deviation they do. You see the cloud size, how many points they have, and they keep them all. So they are definitely going to stack up a few errors as we get back, but they're not really that bad.
Nothing too awful to have to deal with. Let's take a look at our next map and see how Team Dynamo has done.
This one's hard to see. So if you look, the cloud size is pretty small. They are very sparse on their points, and so they don't, if you look at the bottom, that's kind of where it is. It's that they just don't put the points as close together as the other folks do. So you'll see that the coverage is still 25%, and the deviation is small. It's just a little harder to see with comparison to the other folks.
Yeah, so coverage just a little bit more limited using those UAVs in those first 22 minutes or so. Let's take a look at our next team, CTU Krasnorlab. Again, going backwards just a bit, that 28-minute mark. What stands out to you, Julia?
Yeah, you'll see a lot of that orange kind of piled together right in the middle. They definitely had some pathways that didn't exist that they are saying that did. So somebody got turned around somewhere and added a bunch of stuff to the map that isn't true. That actually really affects it when you're sharing maps between the different robots. That really affects your entire strategy, all of your robots, not just the one that's having the problems with the map, because you might have robots trying to explore places that don't exist given the fact that these are part of your global map.
So having to figure out exactly what is in front of them, that's what these autonomous systems are trying to map out and identify as they traverse through these courses. Let's take a look now at Team Barks. Wow, that's a lot of green.
Barks is for Bayesian Adaptive Robotics. So this is not terribly surprising. Sensor fusion is what they do well. So this is a really nice looking map. Their deviation is so very small that, I mean, you can see some, but they're still kind of in that 0% on the how many of the orange are in the set of cloud points that we have at the very top there. So they're doing a great job. Not a whole lot of exploration still happening at the end here. I'm sure that they are collecting the different artifacts and making sure they've got some good localizations to send back.
Well, that's a look now through the virtual competition. You're probably sitting there wondering, well, who in the world won? Well, we did that on purpose. You're gonna have to join us again, of course, at the award ceremony. But before we get there, I mean, how unique, how cool is it to get to see this final World 8 really merge with the systems competition as well?
So I got to see it before y'all did, and I have to tell you that I was so excited to see that it matched up with what the systems was. That is just beyond for me. And to try to, basically you've got the systems where they're focused on the hardware and the real things and the errors and that sort of thing, to then take the very autonomous solutions and apply that to that world. It's obvious that you're going to see differences just because the levels of where the technology are on each of those things. But I think that's good. That's going to give us a lot of information as we keep going and looking at what this all comes out to be, to say, what's the level of autonomy, what's the level of perception, what's the level of our, our robot solutions. It's really great.
What are some of the advancements just from the virtual side that you've maybe seen throughout the DARPA challenge that kind of excite you moving forward, that maybe give us a glimpse as to what's in the future in the virtual world?
So I think that there was definitely a lot of autonomy that has been developed through other methods and means. Autonomous vehicles are one that are really looking at kind of that lower level, can I stay within the lines, can I detect my obstacles, that sort of thing. And so while I'm sure there were advances in this, but I think the main advances that I'm excited about are those global maps, the message sharing between these limited comm types of situations, and the ability to autonomously decide where my robots are going to go.
And one of the other things that I keep going back to, it's the collaboration and the competition that continues to happen through the Subterranean Challenge. We've seen teams not only utilize other models from other teams, but also using that Sub-T virtual testbed on the regular, going through the simulations to continue to try and progress their systems and maybe share some of those thoughts. Does that surprise you, or how cool is that in the robotics world?
This is how we do, I mean, this is we actually thought, oh, maybe they're not going to know who won, and we're like, oh wait, they're all going to talk to each other, because that's just, we are so excited about what we do as roboticists, and we're still learning so much, and so it's always really cool to see how somebody else solved the problem.
All right, well, solving problems is what has taken place in the virtual world. And again, if you're wondering who has won the virtual competition, you're gonna have to stick around, because that's coming up in our awards later on today. But for now, we're gonna take just a short break before we head into our systems competition prize round. It's those final highlights. We'll be back with more shortly. Welcome back to the Subterranean Challenge. I'm your host, Cameron Irwin. It's time to get into the systems competition. And we're going to start off with why it matters. That's the key here. So let's take a look and hear from our sub-T stakeholder. It's going to be Joseph Downey, and alongside me, before we even get there, I've got to introduce the people. Dr. Julia Badger, she's been walking us through the virtual competition, along with, yes, our field reporter, Scott Walker. Welcome in, Scott.
Good to be here.
Perfect. All right, should we head on into the why it matters? We've been talking about it all morning, but I feel like we need to head that direction.
Good.
All right, let's head on over. We've got Joseph Downey, our sub-T stakeholder. He's also the battalion chief of the New York Fire Department. Here you go.
So my name is Joe Downey. I'm an FDNY firefighter. I've been a battalion chief for the last 18 years with the Rescue Battalion, and that falls under the Special Operations Command. I'm also a task force leader for New York Task Force 1, as well as the national representative for all 28 teams in the Urban Search and Rescue Program. In New York City, we deal with a tremendous amount of subterranean environments. So to be able to have technology to assist us in assessing what we have underground, what could only benefit us. And seeing the technology improve from the first challenge to the second, and looking forward to the third one this coming next couple of days to see where we're at and how it could help me as an FDNY battalion chief when we are going to encounter eventually something underground, whether it be a terrorist attack or a man-made disaster. We're going to be faced with many challenges. Some of our under-river tunnels are 1.25 to 1 3/4 miles long. So for any firefighter to try to go in there and come out, they wouldn't be able to survive on a regular SCBA mask. So looking at it from my perspective, hopefully there'll be something coming out of this challenge that the FDNY will be able to use. And if we do get something in our subway systems or any subterranean environment in New York City, we'd be able to use that technology to be able to assess it rather than send people in there, maybe put their lives at risk. I think in any subterranean, you're going to have a problem with communications. That's one of the major problems that we've faced. As well as if it is a disaster or an event that there's smoke and fire possibly, anybody entering needs to be on a mask. And for the long duration mask that we have was the rebreather mask, which go 4 hours. But again, not everybody is trained in New York City, and not everybody will be using them, so they'll be restricted on how far they can go. If we did have the robots or drones that the Sub-T is using now, that would be able to give us a better assessment and the location of the incident without having to send people in there or firefighters or first responders in there and put them at risk. If we have 6 million people riding the subway systems, there's sure going to be a bad guy there once. It's going to happen eventually where he may be having a bomb or he could have some sort of hazardous material. And once they put it into the subway systems, we would be responding as first responders, FDNY, and we would have to assess that environment. And if we had the technology that the Sub-T Challenge is working on, where we could send a robot in first and be able to assess what we have in there, it could be life-saving to our first responders, depending on the incident. So looking forward to the new technology that's coming out of the Sub-T Challenge, and hopefully the FDNY will be able to use that technology when we're responding to an incident in the subterranean environment in New York City, which, as I mentioned, is vast. It covers 5 boroughs, and the underground is, I think, over 200 miles long. So we definitely could benefit from the technology that's being worked on right now.
Now, while we have already covered the virtual and we head into the systems, Joseph Downey does a phenomenal job of explaining the reality of why we need these autonomous systems and what the purpose is. And I know for you, Scott, it's been really neat. This is your first event and you went big. You went with the final event to start.
Yes.
And you've chatted with all of our teams. I mean, how much is the mission and the objective of the Subterranean Challenge really at the forefront of all of these teams' minds?
I think for the teams, what I've learned from them is it's most important for them to have the just advance the technology. I mean, so how it's used, I think they're understanding that it's going to be used in some really interesting real world situations, but they're curious. They wanted to talk to each other. This was like a convention for roboticists, and they're really excited to be able to show off what their contribution to the industry is going to be.
Well, and we talk about contributions, and one of the greatest parts too for you, Julia, is getting to see not only the virtual world happen, but also all of a sudden the systems teams. And you talked about it, you said, I'm a software person. The hardware stuff, that scares me a little bit, but you've got some of your own robots you have to deal with as well. But I mean, how cool is it to get to see that interchange, and what are some of your expectations now heading into this prize round, the final bit of systems competition?
Well, the systems teams had the benefit of 2 days of getting to figure out how their own robots work in that cave. There's differences anywhere you go. Anytime you take a robot someplace, your hardware is going to react differently, whether it's more humid than you expected, or too much light, or this frequency just didn't work out with what I had. And so they've already got that all sussed out. So I'm really hoping to see some real exploration and some real object detection, and to really get to the algorithms they've been working so hard on today.
Well, that's a great point. You brought up the previous runs, right? So these teams, these systems teams, got a chance to have 2 previous runs, run 1 and run 2, as you take a look at those systems teams that are in action here at the final event. But they were able to learn so much from run 1 to run 2. It didn't necessarily have any expectation or anything leading into that final score, the prize round, but it did have a ton of information coming back out as you take a look at some of those teams. And I know we already went with some expectations, but I mean, Scott, I'm going to go back to you, because you got to talk to them after their first run, their second run, and then of course getting to catch up with them throughout the entire competition. I mean, how much learning took place from those first and second runs?
Oh, I think a great deal, but I actually even want to go back to before the event, when they were thinking about what their plans were. So there were a couple of teams. Marble they had 3 of their their legged UGVs. They only wanted to use 2 because one they'd had some trouble with, right? And so just what their plan was going in, and then comparing that to what they were able to accomplish in those first 2 rounds. How you use your resources, how you deploy them, all that is fascinating, and that's what I'm interested in seeing how it all plays out.
Yeah, and I love that, because there were different elements, right, coming in. You're trying to come up with all of these perfect solutions, but one of the big elements of the Subterranean Challenge is you have to be adaptable, right? So how maybe could have things shifted for teams since they arrived and saying, hey, we want to bring these systems on board, and then all of a sudden you're seeing narrow, constrained passageways and going, that's not taking place.
Well, a lot of them Googled what, the Louisville mega cavern looked like and said, oh, limestone, huge formations.
That's a
These
great
are going to be great big caverns. And then they came in and it was like, oh, look how small it is, and the ramp down. And, the DARPA is all about surprises when it comes to these challenges. And why? Because challenges like this, surprises are really what make you move forward, because you have to see, how your technology goes. You don't let somebody give you a demo on their stuff. You want them to give you a demo on your stuff to see how it really has happened.
That's a great point. And just if you are just joining us, it's also important to note before we head into these EOIs that this is the course you've already seen, but in the virtual world. So let's get a little bit more into reality and see how some of our teams did. We're going to walk through this in a relative chronological order for the prize round. So you can see the total time again up on the board. That's a countdown clock from 60 minutes. Now, some of the variations from virtual, you can see the total number of attempts. That's for artifact reports. That's up to 45. There are 40 total artifacts on course that they're looking for, over 10 different types, including that finals cube that they're going to have to try and identify. So identify the artifact and localize it within 5 meters to be able to score those points. Those will tick up again on that left side. And there's the map that you've come to know so well on the lower right hand side. And this is Team Robotica heading off from the staging area.
So I think Team Robotica, Co-Star.
Oh, and we're actually switching quickly. We're going to Co-Star. And this is fun. We actually have seen Spot just outside of our broadcast coverage. He's been walking around already. I think he's done with competition and saying, all right, let's have some fun as this team Co-Star going on with 1 active robot.
I think that's what we saw from a lot of teams. Their plan was to try to use those leg robots for exploration early.
Quick exploration, and that's your legged system. We did not necessarily see that in the virtual competition. As we head quickly again to another highlight, this is CTU Krasnor Lab. We're flying through these. This is just within the first 2 minutes, and look at, they're already into one of those constrained passageways.
That's where these four-legged robots really shine, being able to get over terrain that is irregular and just unexpected. They adapt really well.
Okay, quickly again, coordinated robotics, here we go. And it's important to note too, that map on the lower right-hand side, that's gonna highlight the different sectors of the course as this UGV takes off. So as soon as one of those updates, you'll see cave will turn green, the urban area will turn orange once that has been identified.
We saw Drill in that last view and got that score right away. Drill is one of our new artifacts for the prize round.
And there's some notes on the back of coordinated robotics. They had a little bit of a different look than some of those other teams, but setting up those comm systems so pivotal. What did you learn about Marble?
Well, and Marble, this is one of their two Huskies, or I'm sorry, the two Spot robots that they use, and they really felt like the more simple they can keep their hardware, the more effective they would be.
Yeah, simplicity. Sometimes you build these incredible autonomous systems, right, that go out and map and identify these artifacts. But sometimes you got to little knock it back as you need to still be able to identify those points. That's the key. When I talked to program manager Dr. Timothy Chung this morning, he said, we could have potentially, well, maybe you do it off of map coverage, or maybe you do it off of other things. But I think for this to be scored off of identifying those artifacts, it really hammers home yet again the emphasis to finding potential things that would happen in a disaster situation. Here's Team Cerberus with a different legged robot.
This is the animal, and so there's actually a decent amount of comparison you can do between our spots and our animals on kind of how they're able to handle this terrain. These legged robots, again, are really good when they have these rails that come out, but there's a lower center of gravity that you get with the animal that we, as we were watching yesterday, saw that might have contributed to some points or not points on some of the runs.
Yeah, so different systems, again, even within that legged area as this heads on up. This is Cyro Data 61. Excuse me, Scott, what are you seeing from them? What did you like from Cyro?
Well, and I think their point was they wanted to make sure that these are the slow and steady places where they could get to. And there was a lot of really interesting mobility in tight spaces, even with these. So their vehicles really performed tremendously, I think, and they were happy with that as we talked to their team members as well.
Yeah, and here's another look of one of their tracked systems as you see the lights on board, and this is actually one of their marsupials, meaning there's a UAV on top of the UGV. Could potentially launch off and explore a little bit higher.
There was definitely some strategy that they were using as we watched through this run on when and where they used those UAVs.
And again, this is from their prize round. Just within those first 7 minutes, we're running all of these teams' highlights as if they're running on the course at the exact same time. So no, if you're wondering if we've got 150 robots out on the course, that is not true. We've only got them running at the same time chronologically, kind of in our own reality here. As take a look at Explorer. This is one of those large UAVs. We talked about it in the virtual competition, Julia.
And this is notable in that from the very first 10 minutes, they were one of the only ones to deploy a drone right away, but it had great coverage. It went far, deep. It took on some of the terrain that has been historically even hard for our legged robots over here, and they hit some map coverage immediately.
Well, and you can start to see those pop up on the sectors as well as we move to CTU Krasnor Lab. And oh man, some of the times it's great having legs and sometimes it is not. That's some rubble there beneath that spot.
It's always sad to see a robot do that, but we'll see some of that today.
Next up is Team Marble. As again, this is a spot and you can start to see the subway platform really come to life from the virtual world now into reality. And my goodness, I believe this spot gets awfully close to that edge. I was holding my breath watching this.
We all were. Yeah, no, it's good. You'll see it go around and kind of figure out the different things. This is one of those big spaces, right? And there's a lot of nooks and crannies with those columns. You have your sensor data. You can't see behind them. And then you have to figure out where, when you do go behind them, that places overall in the map. And so it does take them some time to go and search these areas.
searching at the forefront of all of these systems' minds, or at least to start. As you take a look, it's going to actually even get closer to that edge yet again, but luckily it does not fall off. In case you're wondering, it doesn't fall off right there as a look at Coordinator Robotics comes up. 2 active robots, and this is one of those systems that's actually tethered as it heads in.
And that system had problems earlier in the week, and that was one of the things that, as Kevin Knadler was talking about certain things, trying to get all of the mechanics together. They actually didn't get a robot in until 7 minutes into this particular run. Getting the staging area, all of that coordination was a problem for him as he's trying to get his team together. He had spent most of his time virtually doing a lot of work. Getting things into the cave became a little bit hard for them early on.
So Coordinator Robotics had a little bit of struggle from the hardware standpoint, just in terms that tether makes things a little bit difficult, but still impressive to see them go from the virtual into the systems and compete against some of the leading researchers in the world in terms of building that hardware. Julia.
Yeah, absolutely. The tethers are always, you never quite know how it's going to land and what it's going to get stuck on, but it's super useful in pushing that communications node out further. Those hard lines can't be beat. They are much more robust than Wi-Fi.
So let's take a look at how our teams on the systems competition are shaping up just within those first few minutes of the countdown clock at that 60-minute mark. So you can start to see those artifacts reports ticking up. Team Server is up at the top, Team Explorer just below that, and I love the success rate beneath, as well as the map coverage. So great mapping there, even from CoStar Cyro Data 60, or excuse me, as you see those artifact reports, success rate high, but not necessarily a ton sent in up to this point. We'll get into some of those methods as to when they send those artifact reports in, because there's a strategy there for some of those teams. What have we seen already? What do we know just within those first few minutes?
One of the things that impresses me the most about the systems competition is that when you're in the virtual, you kind of just say, hey, go now. And it goes, right? We talked a little bit about this yesterday. It's a lot of work, like Scott said, to get your robot ready, to get it calibrated to the coordinate frame and to get it in. And so the phase deployments, you don't really see it on camera as much, but behind the scenes, those pit crews are working really hard.
Well, I'm glad that you just mentioned the pit crew, because that's one of the focal points as well. You've only got so many people in that staging area, and then the human supervisor is the one sitting at the computer trying to figure it out. There's a lot of pressure on that. You got a chance to catch up with the team's post-run, and sometimes you'd see the team lead, or maybe it was the human supervisor, somebody else. I mean, talk about the kind of the expression of emotion after each of those runs.
Well, I think after each of those ones, we saw a lot of sighs as people just said, okay, all right, one more. How many more do we have to do? And so that the pressure does become a lot for those human supervisors. I think what was most interesting to me there, Team Cerberus got out to a very fast start, and they made a bet. They're using Animal as a different type of legged robot, and that spun off of ETH Zurich. That's really the nexus point for a lot of the people that are in that team. So they wanted to show off really what they've worked on, and it worked out early on for Team Cerberus there.
Yeah, absolutely. You saw them at the top of the board. And speaking of the board, let's head on into some more highlights, because we've got some left now in this prize round. There is a spot yet again from Team Marble, and it looks like they're in some tough terrain. Maybe it's taking a search here as you see the lower right-hand side lighten up.
Yeah, I think it's in that little cavern that you see in the green down at the bottom. And even though those legged robots are really great at this, I mean, if you walked through a cave and it's dark and you aren't really looking down at your feet, you can stumble too.
Moving on over, it's Coordinated Robotics. That's one of those communication nodes that has been dropped off.
That's 3D printed. Right, so I mean, this is something that they're able to do. Again, a smaller scale team, and this is how they solve some of those problems.
So you can see that guy lighten up as we head on over to CoStar. Oh boy, oh, look at the agility of that guy. How incredible is it that that spot was able to recover?
It was pretty incredible. Again, those control systems, it's actually out of communication range. It's not being teleoperated here. So all of the stuff that you're going to see from CoStar in this area is something that it's doing on its own.
That's incredible to witness as you saw it recover, and now it's going, I'm not a quitter, it's going right back up that incline, trying to figure out if it can fit. And by the way, that might be one of the most constrained passageways on the course. Very, very difficult. As we head to CTU Crass Norlab, you can see again their score on the board. Just 5 attempts used within those first 13 minutes or so. They send off a system.
And like I was saying at the last little break is that, sending off these systems isn't the easiest thing. So, you're watching it coming into the doorway and saying, well, why is it taking so long? Well, it's getting its bearings, it's understanding kind of where it's at. And then it's got to deploy. We've got to check our comms, we've got to check our health, we've got to make sure that the coordinates are moving up, right? You expect it to go deeper in X or Y or Z. And so all of that has to happen in this area.
And they had talked before about having a new communication algorithm, that they had done, and it was difficult to test it. So really, this was getting tested in real time, and may have had some issues that they had to work through again. Another complication you don't want in an important competition.
Yeah, no, it definitely takes a little bit of testing. I would say just a little bit. We've talked about the test iteration cycle for these teams as they continue to improve upon their systems. Maybe let's see what we've got up next. 45 minutes to go. Look, we're going to travel back 47 now. This is a UAV from Team Explorer.
Yeah, so we saw this in the last 10-minute segments. This is that UAV that came out front and hit basically all of those orange sections in the back there. It's going up. We saw a few folks do this in the preliminary rounds, but it's really important because you just saw, another score hit there, or another sector being explored. The UAVs are really the only thing that can get up there.
Well, and I believe there is an artifact up there because a backpack, there could be a backpack up there. I think I saw in a previous clip, but I could be wrong as this guy then continues on. This is again Team Explorer.
We go from that big open space to now a much more constrained space, and so the controller has to be able to adapt to that. It does a pretty good job here getting over that turnstile.
And it's also important to note from those runs in the preliminary round, the course also kind of shifted and changed, and maybe those artifact locations as well. So they're having to adapt very quickly from even what they saw just the day before or even the day before that, heading into the prize round. And again, there's that beautiful mural. We mentioned it in virtual. Yes, it was real as well on the course. The perfect descriptor of all of our teams.
And you can see the number of sectors that they had, 18 out of 28 at that point. By the time they had gotten, by this time, they'd gotten actually 55% of the map already covered. So that was really something they understood, that they knew the world, or they were certainly getting toward that point. And then the question was, how many reports can they get? And
in talking to, again, Program Manager Dr. Timothy Chung, and about this team, he said, this is a team that was super eager to get to this because they were looking forward to that cave system competition, which was not able to take place as you take a look at Cyro Data 61. But they said, maybe this is a team that they were looking forward to that cave and then the final event to improve upon from tunnel.
So this was a really exciting point for us because getting through that water feature was something that, at least for me, not all the robots would have been happy with the water at that point, and our legged robot did a pretty good job at it.
Yeah, water, another element.
Yeah, Brendan Tidd said he was pretty excited about that as well, as CoStar had this was the moment.
So this is, yeah, absolutely. Keep watching here, Cam. This is pretty incredible.
All right, so this is Team CoStar yet again, back at that really tough incline. It has now fallen. The question is, can it get back up? And you can start to see arms and legs kind of moving around.
Again, this is the point where they are not in communication with their robot. This robot is doing these behaviors autonomously, which I think is just incredible. Getting up for a robot is literally one of the hardest things that you can ask it to do.
How many other systems even have the capability, as it does stand back up, the resiliency just in perfect view for us. But the capabilities to that, how many systems can do that around the world?
You have to have an arm.
Yeah,
really, truly, to do that, like humans do. But I love how it then decides, let's try this again. So the traversability was at that point still not too bad, and they were like, we're still going to explore. At this point, I think it gives up.
Yeah, it says, okay, I've had enough, finally. There was just a little bit of quit after a little while as we head on into Cerberus, and you already mentioned the different legs from Animal to Spot, and you can start to really see the joint system on the legs here.
Yeah, this is essentially I don't know if it's exactly the same, but it's very similar. Scott says it's the same point as we just saw with Spot. Now, it doesn't mean that Spot couldn't make it up, but Animal was able to figure this out. We think that because it has that lower center of gravity, that really helped at this point.
That's a great point to bring up, and you can see it kind of scanning the environment as well.
And that's the thing about Cerberus, they have drones that they can deploy. They have UAVs. They just chose not to do it. And that was because they had faith in what they were able to provide, just those 4 animals. And then they also have a communications drone that they can use, or a communications UGV that they're able to use to support that.
I like it. So working on the ground as we head on over to Explorer. Speaking of ground, I think Team Explorer was trying to break our course here a little bit.
Oh, it gets a little feisty here with our course for sure. You can even see the camera going. It got free, it didn't break anything, but that was pretty impressive.
Oh my goodness, the robustness of Team Explorer as you take a look at Cyro Data 61, 6 active robots. And again, another Spot walking around.
Cyro is known in our side of this competition for their amazing mapping ability, and really this is just going through and checking things out quite agilely.
So let's take a look at how Cyro did. You noted their maps. Where did they end up? Well, there you go. Just still 2 points at this point in their run. But great job in terms of their success rate, and wow, the map coverage really up there, top notch, as well as Team Explorer. Cerberus still on the top of the board with 8 total points. So now we've hit just a little bit deeper into our scored run. What are some of the things that stand out to you? I'll start with you, Julia.
Well, I like that that people are being a little bit more aggressive with their robots today. So they're trying a little bit harder on, say, we got to get deep, we got to, do what we haven't done before and make that happen. I think you're seeing that in some of the map coverage that we had in that last chart.
Yeah, you could see that, some of those percentages really starting to skyrocket. And for you, Scott, what are some of the things that stand out now?
Well, I think we talked about Team Cyro, right? When we saw their spots. At that moment, talking with Brendan Tidd, who was their human coordinator at the time, they didn't have all the data. So they understood that not all the data was coming back from those spots. And I think as you see that play out, the question is, would they get everything back in time? And it was an issue that other teams had as well.
Okay, well, let's maybe head on in to see where these teams now stand from this point. Here is a look at Robotica, and I believe this is their clue box system. It's a little hard to tell as it's behind that large shelving unit. And this warehouse area, that caused some major struggles for teams throughout the competition.
Yeah, it was tricky for this robot to kind of go through. It's a constrained space. It's also a cluttered space. And when you get into perception, one of the make me demonstrate on my scene, what you would do is find a bunch of different objects and stick them on a table and say, find me this one, which is exactly what the course designers have done in this room. So it makes it hard from a lot of levels: mobility, perception, everything.
Well, it looks like maybe some struggle there, still getting stuck at the bottom. As here is Team Marble. Looks like a UGV and then a Spot working through. And again, they've just about 20 minutes into their run.
I think this one is actually stuck at this point. It has a bunch of communication nodes you see at the back there. Those breadcrumbs are really supposed to be deposited across the course, and so it's unfortunate that it wasn't able to get deeper at this point, but we'll see how it goes.
And I believe this one is heading back to that staging area. Let's see, yep, it's heading back on up to that tunnel just within those first 20 minutes. So it sneaks past the UGV and says, all right, let's talk to our human supervisor as we take a look at coordinated robotics. 7 total attempts now, as this guy looks like he's getting a little bit stuck there.
If that was a survivor at one point, it may not have been at that at the end. It did discover an artifact, though.
I think that's a fair assessment. I think it did assess that was definitely an artifact there. Our survivor artifact getting a little cheeky there. CTU Krasnodar Lab, that's up next. You can see this is the Absalom, I believe, with the flippers. Another look at a different track system, Julia.
Yeah, I haven't actually gotten to see a whole lot of this system work, but it's really kind of interesting. Those flappers are to help get over center, essentially. Those rocks or those rails that come up really tall, those tracks, generally track systems, then they can get kind of bottoms out on those, but these help you accommodate that. So hopefully we get to see that at some point during this run.
Let's see, maybe we'll get it going in a little bit deeper before we head on into our next highlight. See, nope, we're gonna head on next to Team CoStar. This is the team, they've got those 4 Boston Dynamics spots. They've also got the Rolocopter. They brought a plethora of systems. But what did they really use, Scott?
Well, they did get a lot out there, but it's not just a plethora of systems, it was a plethora of people, because that was a team that had struggled early on. They used a lot of material, backed off of that in day 2, and was able to, where they were able to get a little bit more out today. But the biggest thing though is, again, how can you report? And so at this point, not a lot of reports, and so you're going to get a rush at the end of trying to assess all these artifacts.
And this is a team that took second place back at Tunnel Circuit, then ended up winning the Urban Circuit. Those are both in terms of their systems competition, so definitely a tough contender in Team CoStar as you take a look at CTU Krasnodar Lab, and it's a bit of demolition derby.
What we always don't like to see from a standpoint of trying to deploy your robots into different places. CTU does a little bit more autonomy than some of the teams in the systems competition. As you know, that human operator is very involved in many of them. So this is likely something that just happens in the deployment of these robots autonomously, and they're finding that they're getting into a bit of a traffic jam.
So sometimes their own systems are their obstacles. Sometimes we add dynamic obstacles in. Just behind this spot is actually one of those dynamic obstacles. You can kind of see that latch there. That is considered a collapse of a certain environment, and Spot now not able to get through there.
And didn't actually, that animal did get stuck there for, I believe, the majority of the run. So they lost part of that given that dynamic obstacle.
That's a great point. Heading on over to Team Explorer. And this is a different view than maybe we've seen. I believe, is this in the huge space?
This is in the cavern. This was the very first one to get into the cavern. I have to tell you, in our booth, we were literally screaming about this. There is this giant cavern. This is the limestone cavern that we were talking about that they were ready for, right? These teams wanted. There's a steep incline that goes up quite a bit. And of course, at the very top, there's definitely stuff for them to discover. But this was the little engine that could. Remember when that Spot fell down and kind of, rolled over? This thing got through that part too, and we were so excited about it because it was a tight space for this rover. We didn't know if any rovers were going to get through that. This one did, climbed all the way up, hit the top. Oh my gosh, it was so great.
Yeah, and Sebastian Scherer, when we talked to him about this, he said at the time they knew they'd gotten that deep. This was their R3 is what they were saying. They just didn't know quite what happened after that. And sadly, this is what happened after that. What goes up?
There's only one good way down, and this was not it.
The ramp is the only way up, so I'm assuming it's the only way down. I remember walking up that as, oh dear.
Oh, hold your breath, y'all. This is very sad.
Yeah, you only get so much grip, and we're down. That is a very large drop-off in that cavern.
There were gasps in our control room, and I'm not going to point out who might have done it.
It was me. But the wheels are still turning.
Destruction, the wheels still turning. Oh, yes. That's a fantastic and terrible shot all in one. As we take a look at our scorecard, and again, this is still kind of representing that leaderboard as we go. Cerberus still at 8. And you've got the map coverage on the right-hand side. There's Team Explorer. So important to note, too, there are no ties. So this is the correct. We've got tiebreakers in effect. So those definitely come into play in the correct order. So let's head on into another segment. This is where we're going to get to take a look at the maps. Some of these differences between each of our teams. We're going to start with Robotica and how they started off and what they're seeing. Here's a quick time lapse as we go through the first bit. We're already 20 minutes into their run and haven't quite seen much. That might be having a little bit of difficulty to get started. That's a good representation as this one starts to grow off like a tree and you start the deviation. Really struggling for coordinated robotics.
You do see that they do prune their map at different times though too. At this point, unfortunately, I think they pruned it the wrong way. They took out the green and decided to go with the orange there.
CTU Crass Norlab up next, quickly filling in. There's one of those cavernous areas, not the largest, at the back.
Yeah, one point to make note that even though that deviation gets high, that doesn't necessarily mean that you don't localize your objects. We still do have 5 meters, which is a pretty good amount, so it's not terrible for them.
And here's a look at Team Marble. Again, just about 9 minutes in, now 10 minutes, and wow, the coverage awfully quick.
Which would explain why their scoring was so good at that time. I mean, they really did take that simplicity that we talk about and use it for accuracy.
Absolutely, as we take a look now at Team CoStar.
CoStar uses, again, one of those more sparse maps that helps when you have limited comm bandwidth to be able to send around, and so it's just picking the main points. It's a little bit off there. You see that cave is shifted by a few meters at that point. That deviation gets high.
So again, those are the maps that these robots are building as they go into this unknown environment. So they're having to try and find those systems. You take a look at Cerberus.
You see this one like wiggle up and down is because they use that global map and let other robots correct where it is. You see it flip-flop back and forth as it tries to decide which one's right.
That's a great point to bring up, and I love you. The play-by-play from Julia is always on point. As you take a look at Team Explorer.
Yeah, they had that UAV quickly, right? And so this one is why you see so much coming in the back. Even that orange that you see there is not too bad.
But Sebastian Shearer, though, at this point knew that the cave was going to be a problem, and they were trying to find ways around that.
Finding ways around it. How did Cyro Data 61 do?
They're like pristine. This thing is just a gorgeous set of maps. So their SLAM solutions is definitely one of their best features.
Well, that is 100% gorgeous, and you continue to bring that up as well, saying, wow, Cyro's maps are phenomenal. Just some different points of emphasis for each of these teams, right? So maybe it's a research area for a university team where they really focus in, or maybe it's a private sector company where it's all about the hardware. I mean, the uniqueness of each of these teams really on display.
And that's why it's important to have so many teams, right? I mean, you then get the variety of the different solutions, and that's going to help you say, oh, I can pick Cyro's map and I can pick this one's hardware, and it ends up being really cool.
Very cool. And for you, Scott, what are some of the things that now, at this point in our prize round, this is that final run for these systems teams, what stands out?
Well, again, getting to the cavern, what the Cave of Wonders we're calling it, it was really an exciting time to watch this. But now, what do you do to get that data out of there? Because I knew Explorer at the time knew that they were out of data. And so how do you get it back? How do you assess that? That becomes the key for the next 30 minutes.
All right, well, let's head on into the next 30 minutes and see how these teams figure out what the information is down underneath the ground as we head on in. Here is a look, actually. It looks like this is CTU Crass Norlabs.
Oh, this is where I live. All of those terminals, and that's how they control their robot.
As well, there you go. There's a look at some of the things they are seeing throughout.
So we're seeing the operator displayed next to the map, which is really cool.
Now here's a look at Team Robotica. Again, that's back in that warehouse where I believe they struggled a bit, so still sticking around in that back space.
Robotica had a lot of things going on. Martin Louie, their team lead, said he got about 30 minutes of sleep beforehand. They were working on a lot of things to try to get this particular machine to work, and they'd had some parts issues as well. A lot of things going on.
A lot of things going on for Team Robotica. This is a team that designs all their own systems. As we head on over to Explore, again, there's their UGV going over the top of those rails, much quicker than we've seen the UGVs.
Yeah, they already explored this part of the map. I think they were trying to get back and trying to get some data from folks that might have been over there. Those UGVs or UAVs can go more quickly than the UGVs, and so they're actually, if you're sharing that data around, bringing it back out is a good strategy.
Also important to note that those UAVs, because there's so much downforce, right, they're also kicking up a lot of dust, which some of those systems have struggled with. As again, you take a look at what the maps look like for these teams.
right? So we're looking at where Koro Alley's going on their display versus the true map.
The true map, great call there. As Cyro Data 61 is now up. Just a few minutes left to go.
They were the second one to get into that big cavern, and this time it was a Spot that got in there. And so Spot spends some time exploring. Obviously, with that big of a space and it being really the big space to explore, there's probably a decent amount in there.
Yeah, and at this point, they were out of connection.
Right.
So the real question was how to get that data back again.
How do you get the data back? That's one of the many challenges as Cyro Data 61 dealing with the real terrain, the raw terrain, as you can see just down below. There's also another little cave area there that was built in. Take a look, that's it right there. What can you find? And here again, this is a look at the screen of CoStar while they're actually the prize rounds happening.
Right, so they have that sparse map, and so you see those dots there. Those are nodes that they're building their graph from in their sparse map. So this is kind of where they expect their robots to go, a path back, if you will.
Absolutely, and here's another view for you. There's the real map, or the map on their screen versus the map that they're making on the right-hand side.
Yeah, and to orient you, it was rotated about 90 degrees there.
There you go, as CTU Krasnorlab pops on screen. Just 23 minutes left in their run. They have 6 sectors explored as the UAV heads off 7 attempts of the 45 as they continue to try and bump up that score as high as possible.
One of the things maybe to mention here is all of the caging around it. You know, robots are somewhat dangerous, and so are your UAVs. And so protection of our human operators is really important, and that's probably a good place to kind of note it, that that's how that works.
Another UAV now into the urban area, and you can tell a system potentially back on the other side as it continues to flash back and forth.
And at this point, in talking to them after their round, they were aware that at this point they had a couple of UGVs that just weren't in a position to help them. And that's where this drone was their decision to try to make sure and get a little bit more data, a little more information, put some points on the board.
All right, a little bit of a traffic jam back in the tunnel. Again, there's another look at it. There's CTU Krasnorlab. And here is a look at Team Marble again. And that is a very tough area. Not only is it small, but you can see the unevenness of the terrain.
So we were talking about bottoming out earlier with those tracked robots. If you see in the middle there, that really shoots up sharply. And on the either side, which isn't too far away, it gets pretty low. So for those wheeled and tracked robots, that's a really difficult part of the terrain. Their legged robot doesn't do so bad though. I mean, this is what legs are for.
You know what's funny though, is I'm sitting here going, yeah, I think I went through parts like this, and I don't know if I would have done as well as this robot does. I think it might get into some trouble here, but I'm going, yeah, I think I'd roll my ankle right there as it does his, well, figurative ankle, I guess.
Very sad. You never like to see those robots go down.
No, it is hard on the heart because you know how much time and energy has been spent on these systems. As we take a look at the scorecard now, this is again just in the prize round for the systems competition, where they stand at this point in their run, all simultaneously happening at the same time. 12 and 12 are 1 and 2, and Explorer at the 11-point mark. So we don't have much left in those scored runs, but I will tell you what's really incredible is a lot of these teams report late. So a lot can happen in those last few minutes. I mean, explain maybe some of the reasoning there. I know it's all about the information gain and then the return, but how else does that work?
Well, there's some strategy involved in this because one, you don't necessarily have all your nodes out for communication, and so you want to go far and get those points, but you won't necessarily communicate them back at first. However, we do have tiebreakers.
Yep.
So the very first tiebreaker is what is the time that your first artifact was reported, and so there is, again, you want to get that first artifact as quickly as possible, but then after that, exploration rules, and you don't necessarily worry about your comm coverage as much.
Well, that's a phenomenal point. Those tiebreakers do come into effect, so you want to keep your eyes on some of those. And for you, Scott, what do you see now?
Well, I think in talking to some of these teams, they needed to make sure that they were sure. Some of the time the late reporting is about figuring out, is this exactly where I think it is? And I think some of the teams were not as confident about their localization and just wanted to make sure. Certainly that was the case with Team Explorer. Team Cyro also trying to make sure that deep exploration would come back with accurate results. And that really played into their decision making going into the last few minutes.
Decision making is going to be at the forefront, so let's take a look as we head back inside. Some of the big decision points happening now. Cyro Data 61, just 20 minutes left.
So this is still exploring that large cavern at the bottom of your screen. There was a lot to do in there. It's in that tunnel inside of there. I know that while we were watching that, we were rooting for it to go up that ramp too, just to have someone else explore it. But you know, it's a big space to try to find it.
Now on to Team CoStar. The bright lights shining through for Team CoStar. Their UGV heading through.
Rolling through some of that tunnel terrain, and obviously it's been tricky before. Able to do a really good job here.
And you can start to see so many of those sensors on board. And Julie, I'd love in this next clip too to give us a little bit of an education. We've mentioned some of them, whether it's the RGB or LiDAR, but some of the perception techniques used by these teams.
Yeah, you see on this one, there's those three kind of thick pucks. There's like a silver, then a black, then a silver. One's rotating in the middle. There's two that are in the front and the back. Those are LiDAR. Those are one of the best sensors that you have for being able to localize map. That gives you tons of those point cloud data on there. When you rotate it, it gives you kind of the different views up above and below, unless there's something behind it, obviously. They actually have some algorithms that allow them to cancel out the dynamic effects of their vehicle, I think, to be able to take that out of the map, because you can obviously tell that the middle one is actually catching the vehicle as it spins.
Speaking of spinning, here the wheels of Team Marble are spinning down the subway area, and you can also see the spot up at the top of those small set of stairs, one of the many challenges of the urban environment.
But handle them nicely. And Julia, I believe this is true as well. For Marble, their units will communicate with each other. So this is also a way to be able to again, retrieve some of that data that we're talking about.
Absolutely, yeah. I think that the wheeled one that just went by is one of their communication nodes, and so that one was an important thing to be close to.
Well, we saw this same steam area, steam tunnel, in the virtual world. Now here's a look at it in reality. An animal trying to go through from Team Cerberus.
Yeah, there weren't a whole lot of robots that explored this part of the cave, but there is an artifact in there, and so I believe that they catch it right there as they go by. So that was one of the ones that not everyone achieved.
And just 15 minutes left. You can see those reports really starting to tick up. 13 on the scoreboard for Team Cerberus at this point as they continue through that steam tunnel. Here is, again, Team Explorer. There are the big wheels trying to get through some really tough terrain.
And it's designed that way. They are designed to be aggressive, move things a little bit around, and really try to get deeper into that exploration. It has worked very well for them. Their mobility all throughout the day was really good.
And this team, of course, is, like you mentioned, headed up by Sebastian Scheer. They also are out of Carnegie Mellon and Oregon State University.
And this Explorer was going down trying to find some more data, trying to map a little bit more.
As you take a look now at Cyro Data 61.
It's really late in the game, and that UAV still hadn't launched.
And now, again, here's another quick look. This is all these teams at the same time. Team Explorer, we're moving quickly because a lot happens here at the end. Just 14 minutes. That's one way to get over
So
some
what we
stairs.
were rooting for is, this is the one that has the robot that fell down the cliff. And that data nobody had been back there yet, right? And we were kind of like, please go back there and get that data. Don't sacrifice for nothing.
And that was exactly the intention of releasing this drone and trying to get it back into that cavern.
Exactly. That's a great call as the dust then again spewing upwards into that UAV heads on into cave area. Who do we have next? That's the question. What's going to take place in just those final few minutes on course for these teams? Cyro Data 61 Yet again, there, I think this is where we just saw them, right?
Well, it's a tight spot, and I don't think they can get through that way. So they eventually have to decide, hey, let's abandon and get back to where we need to go.
Yeah, and Brendan Tidd was trying to get back into that cavern to be able to communicate with the data in that Cave of Wonders, and they kept getting blocked. So it was about, how do I get around this to get that data?
Yeah, the dynamic obstacle is just creating that much more of a challenge in this situation as we hopefully head on in. That marsupial you can still see rolling on through. There's coordinated robotics. Wheels still spinning a bit. Looks like one of their systems struggling.
It tipped backwards, as you can kind of see that communication node there at the back.
And here is Team Explorer. Yet again, 13 minutes to go.
Still trying to get back to that cavern and figure out what happened to that data that they had there. Well, one thing to note for Team Explorer, the sectors explored 26 out of 28. I think they were the winners of the day for that stat anyway.
Yeah, they only missed 2 tunnel sections.
Yeah, so great exploration from Team Explorer. As you take a look now, CTU Cross Norlab, again, back in the staging area, just 13 minutes to go. They're sending off another UAV. With only 11 minutes left now, Cerberus, where are they as they approach a backpack? Will they correctly identify and locate? It looks like they've definitely seen it. Will it come up on the scoreboard? That's the question for Team Cerberus. 5 active systems on board. Sectors explored, 18 now. You can see it. You can see it thinking. I think there's a fair assessment there. A lot happening within that system. Now, this is where things get fun. This is what we have left in terms of our scorecard. Cyro Data 61, 20 points. Cerberus, 17. Explorer, 14. And there is still so much that happens even in those last few minutes of our run. Things are going to get a little bit dicey. All right. What are you guys most excited for? I know we've seen some slip-ups, some falls, and that definitely hurts the heart because we know what happens to these teams and how much energy, investment, time, and man-hours really go into these systems. But what can they take away regardless of what happens on the scoreboard? What can each of these teams take away?
Well, they have to be proud of all the work that they've done. I mean, this is just incredible. To get here in the first place is amazing, and to get as far and deep in the cave as they did is incredible. The perception, the navigation, the systems of themselves, and just everything that they've learned and taken away from this. I know that they're proud of that. I think a lot of them want to win, and I think they said that, but they're just happy to be here.
Yeah, and I think that's what Benjamin Morel at CoStar was saying. Look, all of our team, there are so many people that contribute, and what we do here is for them, is to validate all of the work that was done. And I think another thing in terms of Team Cyro, their team lead isn't even here. And I had a telepresence interview with Navinda over the last few days. What's possible has changed over the last 3 years. I think we've all discovered that, and these teams have been able to be resilient and rally around it. I think that's what they'll take away, as well as their contribution to science.
Okay, are you guys ready? We've
Can't
got
wait.
just about 10 minutes left. I think it's time to dive back on into the cave, back with Team Explorer. You can start to see their scores still there at that number 13 mark. Sectors explored on the right side. Oh, and all of a sudden, the score pops up as the wheels continue to spin.
And we're really, really rooting for them to get back to that cavern for our poor comrade that fell off the cliff. And so, getting stuck, this was just so dramatic to happen so late in the game.
What else is dramatic? How about Team Cerberus? There's their animal. There's that higher railed edge that we've talked about.
They just start racking up the points. The scoreboard that we had was 16. Now we're all the way up to 18, only 30 seconds later. This was really exciting as well.
And again, they're kind of getting high-centered on that rail as you continue to see those scores increase. I haven't quite seen this approach, using the rail almost as a guide.
It was unique, and I think outside of that one animal that got caught by the dynamic obstacle, the rest of them handled it very well.
And moving on to Marble. This is a part of, it's kind of an office area, as you can, still, again, the detail in this course. Even those walls painted to look like as if they have mold or smoke on them.
Well, Dr. Chung's office is back there. They recreated it in a little bit of a hairy way. I think that one actually got in it.
Oh, there you go. I think that's a security breach right there as you take a look at CTU Krasnorlab. Just under 8 minutes left. Where are they at with their score? 6 on the board. So sending in another system, trying to rack them up right at the last minute.
They have a lot of active robots all at the same time. I think that there was several that got stuck in that hallway there, but they are definitely trying really hard to get the comms to really work.
Yeah, and still sending out systems even that late.
No point in leaving them in the garage. You brought them all this way.
Might as well get them out on that course. See what they can do as Cyro Data 61 pops on up along with that attempt and their score. Ooh,
Yes,
there it is.
So this is me as a layman saying, get the drone up. But what was interesting is the drone is not for discovery. The drone was to get it out of the way so that that bear could get back and report. The drone wasn't going to help.
Oh, that's good to know.
And that's why they did it.
We were definitely asking that in there, but because it did keep reporting. It's actually, there's verbalization on their vehicles, you know, part of that human interface of knowing what your vehicle is thinking without being in front of a computer screen. And so that's very interesting.
So kind of trying to offload their systems, quite literally, in order to get back and report. Cerberus up next. Almost through all of their attempts, but a very solid score now at 20 points.
And they're still exploring. That spot keeps going through and making sure. I mean, obviously at the end you have bounding boxes and that sort of thing on the different artifacts you see on your screen, but you got to make them within 5 meters.
Some big wheels again, Team Explorer going down the tracks. Now with 15 on the board.
They are the ones that just really don't mind being aggressive, and they're keeping going and trying to get all of the points that they possibly can and trying to get back to that cavern where they lost that robot.
And this is a team that has done testing prior to their arrival here at the final event on their own time. They went to a couple limestone mines, so maybe there's some expectation there for what the course might be. We're dealing with some constrained passageways and those rails as Cyro Data 61 pops back on up. Just 5 minutes left, 27 total attempts, a score of 21 points.
And that was that bear without the drone. So to be able to get it back through those caverns, that was what Brendan was thinking about. How can I cleanly get this vehicle back in a way, and losing the drone was the best way to do it.
So they lost the drone and they continue on their path. How far they can get, that's the real question as another piece kind of falls off that system.
Yeah, these were really tight passageways, and that system, it's just very difficult to get something that wide through, but they tried very hard on that.
All right, who do we have next? Here's a look at the screen yet again of CoStar.
Yeah, we're looking at what they're seeing from their map, and then the views that is coming back from the cameras that are on each of their robots, and they're looking through. You see those green boxes there? Those are the bonding boxes that we talked with our YOLO You Look Once type of visualization, and they're going through and saying, hey, is there anything there? You see on the bottom it says fire extinguisher 9%. The robot thinks that these are those things, but only 9 or 8% accuracy, so clearly that's why they're not the actual object.
Yes, so you can see them searching through those images as we take a look now at coordinated robotics. 9 active systems out there, and might as well send one in. They're going over the tethers.
It was 3,200 pounds of robot that coordinated robotics trucked in.
Oh, wow.
So it's a ton and a half. Get them all out there.
That's great numbers coming from our guy, Scott Walker, as they send in yet another one. I believe some of these chassis actually purchased off of Craigslist to be able to build these out. You can see the laptop on there as well. And it's going to run into a bit of a pillar. 4 minutes left. Cyro Data 61. We saw a legged system kind of have the same difficulty. Maybe not necessarily getting high centered, but the legs causing a problem here. Cyro.
Yeah, exactly. So this is where we were talking about how tracked systems really have a hard spot on this, and there's not a lot of time left. It gets, again, it's aggressively trying to get back because this is Bear, I believe, trying to get that comm back, and it can jam itself pretty good. what happens.
Jammed up it is, and jammed up is a system of Explorer.
We were rooting for this.
Oh,
R3, we were rooting for
much.
R3. Still spinning after having fallen, what, 20 minutes before?
Yes, and from that 15-foot cliff.
Oh, just now under 1 minute left, or just 1 minute left. This is Team Explorer. You can see their score 16 on the board. what can they do just in that last minute as they take a look at their UGV. They've done a lot of work up into this point.
It's got to be so hard at that point. You know, you've done your best, you've done everything you can, and now you just have to wait.
Here's our last look of the run. This is from Cyro Data 61. This is back in that staging area. Oh, and look, they're trying to throw out some of those attempts late into this run, very late. There's another attempt. You might as well just kind of throw some out there, see if you can get a couple extra points up on the board. They're searching their maps.
Looking at the different pictures, seeing if there's anything that's good. You know, it's better to not leave anything on the table at the very, very end. Those attempts don't buy you anything if you don't use them, so.
And that's what happened with the Explorer. Explorer had data that came in, but came in after 3 zeros up on the screen.
Well, and I think Co-Star did that same thing.
Right.
Absolutely, and you even just saw another point actually head up on the board just with a few seconds left for Cyro Data 61. Take a look at their score. They're very happy with that.
More than half of the artifacts found, they told me afterwards that they had never done that in competition, so they were pretty proud of themselves.
Oh, that's amazing. As Cyro Data 61, a huge round of applause for all of our teams as they finished off their prize round runs. And it was phenomenal to take you through all of those highlights. I mean, you just saw so much action take place from each of these teams, different approaches around the board. But what did we ultimately learn, Julia?
We learned that we can go back and find stuff in caves. I mean, this is cool. That's exactly what we were looking for. So it's very, very important, I think, what we learned today. And it's not even just today. We're going to be learning on what we did here for years, and that's really the whole point of it.
Well, you bring up a great topic. Even you know, Tim Chung said the same thing, saying we have data that could potentially be like 2 years of discovery even after this, or even 5 years. There could be, you know, dissertations made off of this and research. I mean, there's so much out there. And for you, Scott, this was your first introduction to the sub-T world. I mean, what are your takeaways?
I think my biggest takeaway is hardware is hard. I think that, you know,
Yeah.
and that was what the team's first, you know, Marble first said it to me. Hardware is hard. But I think for what you're seeing is hardware is worth it. Once you start to continue to see how much data comes back, what it can do in the real world, virtually it helps, but eventually you have to go out and find survivors. You have to go get things. And this is the ability that is made possible by this competition.
Awesome. All right. Well, I think that gets us done for the two of you, or at least for Scott. Thank you for joining us. Thanks for all your hard work, chatting with all of our teams. It's been incredible having you on board with this awesome, awesome crew. All right. I think it's time to head to our journey. We've got a little bit of a view in terms of video to see us from the beginning all the way back at Competitors Day to right now here at the final event. Take a look.
Challenge is about developing and defining the problem, not about defining the solution. That's what you all are here to be able to contribute to. We are here to provide that challenge problem, provide appropriate bounds, but not confine you to a very specific, narrow approach, but rather to explore with a very wide aperture the types of solutions that, quite honestly, might have been unexpected. And that's where we see the greatest value of doing a DARPA challenge.
This challenge has the opportunity to create that environment for innovation.
I think that the toughest thing academically about this is having multiple robots work together with very limited human interaction.
You can't just have one thing work, right? You have to have 5 different things simultaneously working, and getting to that point is extremely non-trivial, but I think that that's ultimately the real value.
Testing is very essential.
We have a really interesting approach where all the robots are sharing maps with each other.
Visualization, understanding where the robots were and where they needed to go next was the challenge.
It's been a lot of work, is really what it comes down to.
I I learned enough to be able to use the ground vehicle.
I've tried to keep things as simple as possible in the behavior of the robots, how they move and explore as they search for artifacts and try to build up a map of their environment.
We had much problems in localization and also with the flying of the copters.
We programmed the basics of moving the robot along the tunnels, which is a simplified environment. We implemented object detection for the first time.
Our robots communicate with each other and then they try to exchange minimal information and important information.
Or having the robot understand and process what is meant by interior space.
As they go, they build a local height map.
Eventually, they're going to get close enough to the base station to report all the artifacts that were detected.
The urban is essentially 3D environment, not just 2D topologically. We had to improve our navigation, mainly the exploration mode, to be able to go to the 3D.
Since we are only allowed to have one operator, the load is very high. So we're trying to minimize by maximizing the autonomy and making the robots as smart as possible.
We found that communications is a problem, so that's something we're actually focusing a lot on.
I think for the next 6 months, our team is just going to go deploy. We're just going to go practice.
Clearly, this is the world's top research group, industry groups, coming together to solve this unique challenge.
Our initial goals for our robots are to go find artifacts. We think that the virtual is a chance to showcase ourselves.
These are the Super Bowl of the engineering and scientist community. The test is just Pac-Man. Everywhere we haven't been, there's a little dot, and our robots gobbled them up.
Learning new technology, collaborating and exchanging experiences, information with some of the other teams. Just, participating in this part of the research is the reason why we are doing it.
All right, we've done a little bit of a switcheroo. Scott Walker has now headed off. We've brought back in Program Manager Dr. Timothy Chung, and this has been your baby from day number one. And I say it all the time because you take care of it just like one of your children.
Absolutely. No, it's just so exciting to see all these children basically grow up and mature to culminate here at the final event.
So I guess one of the things that's most interesting to me is now that the competition has completed, and we still obviously don't know the winners for both virtual and systems. You're going to have to find that out back in our awards trail. But what have we learned through this journey? For you, what are some of the big key pieces that really stand out, Tim?
Yeah, I think some of the most amazing things here are the fact that you have teams of robots working with humans. And so it's all about how you think about combining the best of both worlds to be able to exploit the advantages of each. And so I think the insights that you get from partnership, just like you do on a sports team, you really have to learn all of your teammates' strengths and play to them.
And that's one of the unique elements too, right? It's not just one singular system being sent out into an environment. These teams have to really focus on the collaboration aspect of this, not only the unknown environment. How important was it for you heading into this to have it be a team method versus just a singular system?
Yeah, I think part of the challenge model is offering up the bold problem and seeing what people will come to the table with, right? But the problem was so massive, the scale and scope of these types of environments, the challenges that these robots are going to have to face, definitely warranted using multi-robot systems to try to tackle some of those problems.
And then I know that Julia already asked you this at the beginning of our show, what's the next step for the Subterranean Challenge? Maybe even more so these systems heading off into the future. We've talked about it in the past. It was all about autonomy and self-driving cars, right? And all of a sudden we're into robotic systems, searching the urban underground and the tunnel systems. I mean, what's the next step here now that the competition has truly completed?
Yeah. I think some of the, this is like, as you said, these are my children in some ways, and they've all started to grow up, and now they have to leave the nest and go off and have that impact that we're all looking for. What I would love to see is that these robots make it into the hands of first responders, even if it's just to train or educate a little bit, get them more familiar with the up-and-coming technologies that we know, because of the Sub-T Challenge, will be hopefully in their hands as a product in the future.
One of the other unique areas that we've talked so much about, but I know has been a real point of pride, and as it should be for you, is that this is not just about a competition, but it's all about collaboration. And we've seen that across the board, from virtual to systems, from sharing models, the open sourceness of all of these pieces. I mean, speak to the pride you have of the community and what that means moving forward that you've been able to build here with Subterranean Challenge.
One of the things that impressed me the most was taking a walk in this team garages down where all the teams are all mustered together, and every time a team was getting ready to come up to the staging area for their run, there was a round of applause as these teams were kind of getting trammed up here. And that level of camaraderie, the community, the knowing, the recognition that someday in the future they're going to remember, hey, there was this other fella or other robot, engineer that might be able to lend me a hand. Let me give him a call. I think that's the type of community that this is all about, and I'm so proud of everyone to have been able to do that here.
Is it a little surreal now that we're back to the end now? Is it weird that we finally made it here through this so many year journey?
It is and has been an incredible journey. I think everyone will attest to that. I think it brought together, DARPA, many of our friends and family in the context of our broader community, certainly the research community, and then our stakeholders as well. And this was a chance to kind of unite the clans and really rally around this really tough problem. And it's been so much fun to see that. Yeah, I think surreal is a good way to characterize it.
Yeah, we're going to find out, I feel like, in the next few weeks how roboticists take vacations, because I think one is definitely needed for everybody after this. It's been an incredible journey, but hey, it's not over, because we got to figure out who the winners are of both the virtual and the systems competition. Here is what we've got left on our schedule for today. So if you want to find out, well, take a look at those times. We'll also get a chance to chat with our teams in both a roundtable for the virtual competitions teams as well as the system competition teams. So you're going to want to stick around on our coverage, because you're going to get to hear from those teams as well. And thanks again so much for joining us and walking through the highlights of this prize round for both virtual and systems. I'm Karen Owen, and from the rest of our crew, Dr. Julia Badger and Program Manager Dr. Timothy Chung, thank you so much for joining us on Sub TV. We'll see you back at the awards show.